Got it. All right. Let me get these last couple of students before we get started. Student. P, this student. Okay. And, okay. Ooh. Student, okay. And then let me check the chat. Let me check the chat real quick. Let a man come on. Okay. Let's see. So it says, are we still good to leave? Yes, right? This is a remote asynchronous, so you're not obligated to stay. My audio is muted. Did you answer the question? Yeah, this is remote asynchronous. Sorry, I was having difficulty doing the Zoom. It's no worries. I think I got you. Okay. Yeah. Yeah, okay, so the student. Okay. And let me share my screen. Okay. So let me see as far as announcements go. So I'll be back. I'll check back on Zoom in about 12 minutes, just for like any struggles. I usually check it again at like the 15-minute mark for just, attendance and for the chat. As usual, feel free to unmute yourself and ask questions or type in the chat. Either unmute yourself to get my attention to ask your question or type in the chat. Usually by the time I get to you guys, so I have a 3 o'clock and a 4 o'clock. My energy is like gone. I'm spent. So that's why I shift into working in the homework. Now, usually what I would do, since this class meets twice a week, on Mondays I usually go to the lecture, but I don't want to go to the lecture anymore. I've been saying the same stuff day in and day out, and it's like droning. So that's why I shift to going to the homework view wall, just to kind of, so I can bring some life into it. I do encourage you to watch the lectures. Like, you can either watch, what's probably better is that you watch the full lectures where I did this like a year ago, because that's going to have all the details. You can see what I did with the students in the morning, but that's still not going to have everything. They still need to kind of go and make their way through those presentations. So what I think that I'm going to do for you all is still go ahead and let's start on the homework. And then maybe on Wednesday, I might come back and do the lecture presentation, or we can finish out the homework. Let me see. So just as a friendly reminder, this is online with lab, right? So for our portion, the online component for our portion is going to be Pearson. That's our online management tool for homework, quizzes, and exams. But this class also has a lab component. The lab component, to access it, is on our Blackboard page. On the left-hand panel, there's a link that says, let me see. There's a link that says Online Alex Lab. You click on that link in the burgundy panel and contact Dr. Lamar. She's the facilitator for the lab. And basically whatever she says is what you need to do. She's going to give me a grade based on whatever you've been doing for her. She's going to give me that grade, and I'm going to scale it to count for 10% of your overall grade. So she has all the details as far as what it requires, the rhythm, the goal, objective, stuff like that. Also, so this is the top of week 3. So with this being week 3, our exam 1 is going to become available next week, right? And I think I scheduled it to open up this upcoming Sunday at 11:11 a.m. And just as a courtesy, I think I scheduled some prerequisites for the exam. In order to access the exam, you have to pass the corresponding quizzes. So quizzes for weeks 1, 2, and 3 for this exam. All right, I think the quizzes should be like 5 questions, so you got to get 4 out of the 5 correct in order to take the exam. Also about the exam, so with all of our assignments on Pearson, including exams, we get unlimited attempts. and the system is set to take your highest score. Now, when it comes to the exam, each time you take one, you don't get feedback until you submit the entire exam. And then, you know, every time you take the exam, it's going to be a whole different set of questions. Not that the questions have been shifted around. I mean, it's going to be like other questions. And so, but it'll be the same content, but just a different set of questions. So each time you take the exam, it should give you a different set of questions. So I'm saying that to say you want to have some level of proficiency going into the exam. Otherwise, you may or may not be able to get through it. Trying to think what else is pertinent. So I just had the reminder, be sure that you're doing the online Alex lab, and also be sure that you're doing the Pearson assignments. These are two different systems, which is very easy to lose track of. Again, if you have questions, feel free to either unmute yourself or type in the chat and we can talk about it. So I think for today, I do want to kind of start on section 1.3. I think we can make our way through the homework and it'll be fine. If we need to go back to another section, I think going back is okay. Going forward, let's just try to, I don't want to talk about 1.4 just yet, but if you want to talk about 1.1, 1.2, or 1.3, we can, right? Go ahead.
Excuse me.
Mm-hmm.
When's our first exam, sir?
Give me just a moment.
All right.
Let's do like this. So the first exam is this upcoming Sunday. It's available this upcoming Sunday. It's due the following Sunday at 11:59 p.m.
All right.
So it's available for 7. But again, we can work on any assignment past the due date with only a 10% late penalty. Keep in mind the hard deadline for all assignments is that Friday at the end of the week of finals. That's like that first Friday at the end of the first full week in December.
And I have another question, sir.
Yes.
Can we still retake, since it's unlimited, can we still retake an assignment after the deadline has passed? Let's say we tried multiple times and we still don't like the score we get, but the deadline, the official deadline has passed. Can we still retake it and then get that high score?
Yeah, but there's a 10% late penalty.
Okay.
Right? So any question that you submit past the due date, it's going to be the highest you can earn is at 90%.
All right.
All right. These are good questions. So, again, I'm just shifting into the homework just because this is I've talked about the same thing. If I did it with you all, that would be my third time today talking about this information. So I just change it up so I can not be falling asleep. So let's start with section 1.3 functions. We don't have that much work, but we have things that we can do. So I think today, we're working on homework, and then maybe on Wednesday I might go back and do the lecture. I might poll the audience or something on Wednesday, but for right now we'll do this. What do I press? Is it not going to work? Let's try this again. It should be this. It's not that one. Why is that not working? Ow. Yeah. Maybe it's this one. Let's see, is that working? That's working. Sorry, give me just a moment. Maybe it's a different key. Is that that one? Let me close out all these tabs. Close out 13. That's fine. You reboot this. Was here? Oh no. He has to. What time is it? It's still got 5 minutes. Like this. I'll get them in just a minute. Okay. Try this again. This one. This one. Cool. Okay, this one, this is the 3 p.m., so let's use that one. Low. 1.3, start. It would be nice. There we go. Yeah, I just had to reboot it. Okay. So if we're making our way, okay. So the way this is pictured right now, this is what's called a correspondence diagram, right? So section 1.3 is on functions, right? And the brief synopsis of what a function is basically you have the set of input values. In this case, it's listed as 22, 25, and 1. You pass it through a function or an equation, and the function generates a set of output values. In this case, our outputs are 15 and 16, right? So in order for this to be a function, every x has to correspond to exactly one y. You don't have one x or one input corresponding to multiple outputs, right? So in this case, the inputs are on the left, the 22, 25, and 1, and none of them are splitting. If you had an input that split to more than one output, then it's not a function. What you see going on here, I like to call this a merge. We have two different x's going to the same y, that's okay, all right? So a merge, that's okay. When you have 22 to 15 and 1 to 15, that's okay, all right? So is this a function? We're gonna say yes, okay? Come on, let's try another one. Okay, so the domain is gonna be your set of all input values. In this case, our set of inputs, let me go to my settings, turn that off. My set of inputs here are gonna be what? 22, where's my comma? 22, 25, and 1. I'm gonna just hit enter. Okay. So if my domain is my set of inputs, my range is my set of outputs. All right. So my range here is 15 and 16. So I'm gonna hit 15, 16. Okay. Next question. Okay, so it's asking for the domain. Again, the domain are a set of inputs. So our input values, let's see, right here, can I do -3? Oh. So then -3, comma, -2, comma, 0, comma, 1, 2, and 3. Okay, it's my domain. And then my range, again, are my set of output values. So you have the -4. Come on, there it is. -4, 0, -5. So notice I'm not repeating the ones that are repeating, right? Okay, let's check the answer. What did we miss? -4, 0, -5, -3. Type each answer only once. What are we missing? Oh, we did -4 twice. All right, I didn't even realize we did -4 twice. Okay, I think that was it. Okay, so is it a function? So again, every x has to correspond to exactly one y. If we have any repeating x's, then we say it's not a function, right? Notice we don't have any repeating x's, so this is functional, so we're gonna say yes. Okay. Does this equation define y as a function of x, right? So given something like this, let me see if I can zoom in just a little bit. Hey, come here, come here, come here. Come here, come on, come on. Come here. You gotta go to the bathroom or something? No? Okay. I need you to chill. We're trying to have class right now. I know you want all the attention, but you're gonna have to chill. Okay, so with something like this, right, we can basically look at the graph, right? So if we have x plus y equals 49, we could solve for y. So if we get y in terms of x, this is basically gonna be y equals -x plus 49. To graph this, we can choose different values of x, find the corresponding y, plot the points, right? This graph is going to be a diagonal line, has a negative slope, and a y-intercept of plus 49, right? But if it's a diagonal line with a negative slope, can we find one x that has more than one y? Right? If you have a diagonal line, no, right? Every x is going to correspond to exactly one y. So if you were to look at the graph of this, that's an example of something that would pass the vertical line test. And so what they're saying is like, if you can draw a vertical line through a graph and it touches it more than once, then it's not a function. But if we have a diagonal line, no matter where we draw the vertical line, it's only going to touch the graph once. So then this is a function. We're going to say yes, right? But the thing there was that we basically looked at the graph. I just didn't write it or draw it out, right? We could choose several values of x, find the corresponding y. Notice that you won't be able to find a value of x that has more than one value of y. Now this one, we want to know, does y define, does the equation define y as a function of x, right? So if we were to solve for y, right, we got that y squared. In order to get rid of the y squared, we had to do the inverse operation. What operation undoes or is the inverse of squared or exponent? A power function, right? So if we have y squared, to remove the square, we take the square root on both sides, all right? So then if we take the square root on both sides, whenever we take square root or an even root, we do plus or minus. So because of that plus or minus, we're going to have like plus or minus the square root of the right-hand side. That plus or minus is basically going to make it so that we can find, given a value of x, we can find more than one value of y. So each x is going to correspond, well, most of the x's are going to correspond to more than one y. For instance, if x were 2, right, 2 squared is 4. So 1 minus 4, well, we can't do that one. I guess we would have to do something like a half, right? Because we're going to be taking the square root of a negative, so we don't want to do that. But I think like for x, if x were a half, right? So then a half squared is going to be a quarter. 1 minus a quarter is 3/4. So then if we did plus or minus 3/4, now when x is a 1/2, it corresponds to two different y's. Plus the square root of 3/4 and minus the square root of 3/4. So because we can find x values that correspond to more than one y, is this a function? We would say no. We would say no here, right? Let's check. Okay, but it's mostly because of the plus or minus. Now, say we were given something like this, where we have y equals the square root of this guy here. So this graph is going to be the top half of a sideways parabola, right? Suppose you weren't aware of that, you can choose values of x, find the corresponding y's, and plot the points. Now, in general, when it comes to square root functions, can anybody tell me what kind of values can we not take the square root of if you limit it to the reals? What can we not take the square root of? Right, let's play with some numbers, right? So say we consider like the square root of 0. That's going to be 0, so that has a real solution. The square root of 1 is 1 because 1 times 1 is 1. Let's see, 4, right? The square root of 4 is 2 because 2 times 2 is 4, or 2 squared is 4. Square root of 9 is 3 because 3 squared is 9. So square root, you're looking for some real number that would multiply by itself. It gives you that radicand. So, long story short, we can't take the square root of negative numbers, right? Numbers less than 0. So we would have to set that x plus 4 greater than or equal to 0. So because we can't take the square root of negatives, well, that was just on the domain. That was just a discussion about the domain, right? So when you're choosing your numbers, you know that radicand has to be greater than or equal to 0. So then x has to be greater than or equal to negative 40, right? So anything to the left of negative 40 is going to give you a non-real solution. Anything to the right of negative 40 will give you a real solution. But that was about domain. If we want to determine if this is a function, then again, this graph is going to be the top half of a sideways parabola. So if you have the top half of a sideways parabola, no matter where you draw a vertical line, it touches it once. So that's going to be a yes. I know that was all verbal. We didn't draw anything. You can choose several values of x, find the corresponding y, plot the point, look at the graph, right? That's essentially what I was describing, was the graph. With this one, right? If we solve for y, right? If we try to solve for y from here, eventually we're going to have to take the square root and we're going to get a plus or minus, right? Let me see, if we subtract the x squared, you're going to have 4 minus x squared. You take the square root, you're going to have that plus or minus. Again, in this context, because of the plus or minus, you can find one x that corresponds to more than one y. So then, does this equation define y as a function of x? We're going to say no on that. Right? It's mostly because of that plus or minus when we go to solve for y. Now here, if we go to solve for y, right, we subtract the x cubed on both sides. So in the previous example, we had y squared and we took the square root on both sides. But in this case, we would take what's called the 7th root, right? Whenever you take an odd root, you don't need plus or minus. You only need plus or minus when you're doing an even root, right? So because that y is to an odd power, when we go to solve for y, we're not going to do the plus or minus. So then does this equation represent y as a function of x? We're going to say yes. It's going to pass the vertical line test. You wouldn't really know that unless you came across something like this. Now, I'm going to go ahead and check this one. I want to do a showcase here. I don't want to do a next question. I want to do a similar. Let me zoom out some so we can see our options. Now, suppose you're working on this and, obviously it's not that obvious, right? I'm going to hit similar question just to see a similar one. And I'm going to click on get more help. And the one that I recommend, the textbook is the digital ebook. So if you wanted to scroll through the book, you can. Ask My Instructor kind of is like a last resort if you just can't figure it out. Between yourself, your classmates, the tutors, then you would want to use the Ask My Instructor. But the one that I recommend is the View an Example. The View an Example is one of the main reasons why I vouch for Pearson. It's just most of the questions in the homework have that View an Example, and it gives you a detailed explanation as to the logic or the reasoning behind why the result is what it is. It's not only just giving you an answer, but it's giving you a reason why that's the answer, right? A lot of this experience in math, we're less concerned about the answer. We're more concerned about why something is the correct answer. So if we look at the View an Example, it says it's a total of 2 parts remaining. We have a similar example to ours, and it says to determine whether this represents y as a function of x, solve for y in terms of x. If 2 or more values of y can be obtained for a given x, the equation is not a function, right? Okay. So then you see here, you can see the 7th root, right? Like what I think in our example, we did 9th root or something like that. But it's an odd root, right? So you have details on a step-by-step. Now, since this equation has an odd nth root, namely that 7th root, there is exactly 1 corresponding y in the range for every x value. Therefore, this equation does represent y as a function of x, right? I'm going to close this one. I want to go back to the previous one. So this is an example of something that is a function. Save the best score. I wanted to do a similar, actually I want to do the View an Example for the one that failed, right? So this is the previous one. Write y in terms of x right here. And then when you go to solve for y, notice we have an even root. So we had the plus or minus, and then it says right here, the plus or minus in the last equation shows that for all values of x less than 14, there are 2 values of y for this reason, right? So because of the plus or minus, I was kind of hoping it would say something because it's even root, right? But because of the plus or minus is why that one failed. So let's go forward. But yeah, so the get more help. So like if you're like sitting down with the tutor and suppose the tutors might get stumped on some of these, but not for this. That should be minimal. Hey Siri. Hey Siri, stop the timer.
There are no timers on HomePod.
Okay. All right, it worked. Okay, that's all I needed. So let's look at this example. Let me pause for the cause for a moment, and hopefully you guys, it's not too intense because I know it can be kind of intense. I just want to check. Okay, we got some questions in the chat, and we got some stragglers. Oh, okay. Let me get these guys. So that is, you want to be careful about not being in attendance because it might seem light right now, but it's going to turn up. And it's gonna the pace is gonna rev up, and you just want to be careful about not paying attention. I mean, again, this stuff is live streamed, you know, but if you feel like you can get it on your own, I mean, and it is designed for you to kind of get it on your own, just be careful. And I understand my presentations, I get it. That's why I did that, just to make it easier for everybody as far as setting the course up. Just, you know, just be careful. Make sure that you can like get what you need. Let me see. Yeah. If you, telemarket. Yeah, you don't have to. So as long as your ID, as long as your screen name has your student name, and then, you know, because I'm taking attendance as I'm letting people into the session. So as long as your student name is showing and you get into the Zoom and I don't say anything, that means you've got an attendance credit. Okay, so let's look at this one. We're asked to evaluate this function at these different values of x, right? So we have, you know, these different examples, and then we're given this function, right? Okay, now we can do this by hand, right? And there's nothing wrong with that. But what I'm gonna do, I am gonna showcase my virtual calculator. So, like this, that's what I want. And then this, right? So we got this virtual calculator here. So this is a TI-83 Plus emulator, right? It was developed by some students at another institution. I was looking for something like this for years, and then I finally found something, and I've been using this for years, right? It works really well. And so this is a way for you to kind of see the calculator in a digital platform remotely. So now we can take these values of x, plug it into our function, and calculate it by hand. Type an exact answer using radicals as needed. That might throw us for a loop a little bit. Okay, let's start by trying to plug it in. Now, if it wants exact answers, we might have to go back and write these out. Now, to type this in, what I did, in the upper left-hand corner, I hit my y equals, right? And then I'm going to type the function. Now, this, you do need to use your parentheses properly here, otherwise it won't work. So I'm going to say the square root, because the square root already has its own set of parentheses. I'm going to say my 16 minus x squared. Okay. So we have the entire denominator group together, so we're good to go there. And hopefully, you know, right now, I think we'll get some results that might not need radicals, that won't, you know, if we get long decimals, to get that exact answers, we're going to have to use radicals, so we might have to go back and write it out. But for the simple ones, we're going to do this. Now, if I had a TI-89 Plus emulator, then I think that it can give you the exact answer. But, you know, I haven't gone to look for one of those. Okay. So now we want to plug in when x is 0, right? So on the right-hand side of the calculator, there's a button that says clear. To the left of that button is a button that says VARS. I think it stands for variables. I'm going to click on variables. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function, and then number 1 again for the function that we typed in. I'm going to do open parentheses, and then I want to evaluate this function when x is 0. Right? It'll look like this. Let's see what happens. We get 0, right? 16 minus 0 is 16. 0 divided by any real number is 0, right? So then part A, I think we get 0. Oh man, come on. There we go. 0. Okay, let's try another one. Now, as soon as we get decimals, we might have to go back and actually write it out. Okay, so I'm going to recall. I'm going to hit second enter to call on what I just had. And then I'm going to change the 0 to -4. Okay, and let's see what happens. So it says divide by 0, right? So let's confirm that. If we put in -4, we have to do the exponent first. So that's going to be -4 times -4 is a positive 16. 16 minus 16 is going to be 0. We're going to have -4 divided by 0, right? So we can't divide by 0. So then we're going to say it does not exist. All right, I'm going to check that one. Not a real number would be like if we're taking the square root of a negative, right? So let's see what happens when we plug in 7. I think that's what happens here. When we plug in 7, 7 squared is going to be 49. 16 minus 49 is going to be a negative number. When it comes to square roots or even roots, we cannot take the square root of a negative number. Right? We cannot take the even root of a negative number. So because we're taking the even root, namely the square root of a negative, we're going to get not a real number for that. Okay. You have to stop me if anything is not clear or anything of that nature. Okay. 3/2. We might need to write this one out. Let me try it in the calculator to see if we get a clean result. I'm going to hit go to. Oh, that's good. So then I want to recall. Can I just recall? Okay. So now we're letting x be 3/2. So I'm going to do 3 divided by 2, close parentheses. Okay. So because we got that decimal, we might need to work this one out. So let me get a copy. I'm going to get rid of this. Zoom in a little bit. Like the stuff that we're talking about is not trivial. Like it's not obvious, you know? And so then, you know, again, as long as you get it from somewhere and as long as your source is legit, then I'm okay with that. You know, I can get past whatever. Come on. How did I fix it before? I hate to do that. Okay, let's do it again. Oh, there it is. Man, that's such a pain. Okay, there we go. Okay, so let me get a copy of this and let's work this one out. My device is totally like throwing a tantrum. It's just old. Like it's time for it to be replaced. And I think it knows it. And so it's just like, it's literally just throwing a tantrum. Like I'm constantly having to reboot it for it to recognize my touch. It's 3:33. Okay, let's hop over to this. Good, that's still there. Okay. We started by getting a copy of the original. This is fine. Okay. So let's write this one out. So we want to evaluate G of 3/2. So basically what we do, we replace each X with the 3/2. Okay. So the first thing I'm going to do is replace each X with a blank set of parentheses. So I'm going to have my 16 minus X squared, square root. And on top, we got X, right? And then what color goes into the blank parentheses? The blue thing or the 3/2. Okay. So let me see, that's going to be what, 9/4? 16/1, 32, 64. So if we're going to say 64/4 minus 9/4, we got the square root of that under 3/2. Okay. That would be 54. So that's 55/4. Okay. So then we get 55. Oh, no, that's not a 55. 55/4 square root under 3/2. Okay, so we can do the following. We still got 3/2 on top. We can rewrite the bottom as the square root of 55 divided by the square root of 4. Let's just write it right now, square root of 4. So that's a 2. So then whenever you say one fraction divided by another, we use a technique called keep, change, flip, right? We keep the first fraction as is. We change division to multiplication. We flip the second fraction. So that's going to become 2 over the square root of 55. Okay. So then these 2's end up canceling. And we have 3 over the square root of 55. Now, usually we would rationalize I think leaving it like this for our purposes is gonna suffice. All right, can I paste? Nope. Let me do this. Let's try that one more time. Let's copy. Okay. Now we can check this before we submit it, right? When we plug it into the calculator, we got this 0.445199,175, right? So we can compare it to our result. We can say 3 divided by the square root of 55. Oops, right there. We should get the same result, right? So that's a good omen. Square root of 55 is 5 times 11, so no perfect squares there. So we're not rationalizing right now. This one. Come on. Okay. So right here, I think we said, was it 3? Three divided by the square root of 55 divided by, now square root, like this, SQRT, square root of 55. There it is, 3 divided by the square root of 55. Okay, let's check the answer. All right, so that one was an adventure, right? Because if we tried to type in that decimal, it wouldn't give us credit for that, right? So we can use a calculator for like simple ones, but then if we're trying to get credit, we got to be a little bit more innovative. I think we got time for 1 to 2 more. Just depends on how long they take us. Okay, for the domain, right? So we kind of got a glimpse of this. So this is one of 2 cases. Whenever we have like a rational function, basically something like this, it looks like a fraction. The domain, in general, the domain is all reals except any x that makes the denominator 0, right? So let me say that one more time. In general, for a rational function, the domain is going to be all reals except any x that makes the denominator 0. So in order to find the x that makes the denominator 0 here, we set the denominator equal to solve. We set the denominator equal to 0 and solve. And we'll get that, we'll see that when x is -4, that makes the denominator 0. So we have to throw out x equal to -4. So we want all real numbers except -4. So all real numbers except -4 is going to be D. I think part A is just taking the numbers to the left of -4. Part B is just taking the numbers to the right of -4, but that's not the complete set. Part C used the wrong grouping symbol for the -4. That bracket means we include -4, but we don't want to include -4. So C is not correct. So then we're going to go with D. Okay. I think we got time for another one. Right, okay, so again, in general here, the domain is going to be all reals except any x that makes the denominator 0. All right. So if we set the denominator to 0 and solve, let me see, you add the 4, square root of 4 is 2. So you'll get plus or minus 2 when you take the square root. So then the domain here is going to be all reals except plus or minus 2. It asks us to put our answer in an interval notation. So we want to capture everything except plus or minus 2, right? So if we start from the far left is going to be -infinity. So I'm going to hit negative INF up to, I think we said -2. The -2 gets a parentheses because we don't want to include the -2, right? Then I'm going to hit cup for my union symbol. And now we want to go all the points between -2 and 2. Again, the 2 gets a parentheses because we don't want to include 2. Cup, that's our union symbol. And then we want everything to the right of 2. infinity, right? So to capture all real numbers except plus or minus 2, the interval notation is going to look something like this. Check. Okay. We got a little bit of time. Let's do one more. Right. Okay. So for this one, now we're still working with a rational function where we cannot divide by 0, but there's an added stipulation that we cannot take the square root of a negative result, right? So I think one of the examples was finding the domain of a rational function was basically all reals except any x that makes the denominator 0. Now we have the second one, which is when we're taking the square root, the even root of a number. We cannot take the even root of negative results. So that x plus 7, that radicand, has to be, normally it would be greater than or equal to 0, but because it's in the denominator, it can't be equal to 0. So that x plus 7 has to be strictly greater than 0 in order to be true. So if we say x plus 7 is strictly greater than 0, subtract 7 on both sides, it's going to be x is strictly greater than negative 7. So if x is strictly greater than negative 7, that means we're talking about all the numbers to the right of negative 7. So we say parentheses, negative 7 up to infinity. Now we use the parentheses on the negative 7 because we don't want the denominator to be 0, so it cannot be equal to negative 7, right? Okay. All right, I feel like that's enough, right? So, I know there was a lot of audible stuff. I could have written a lot of that down, I just didn't. But hopefully you were able to get something out of this. I do encourage everyone to, I do encourage like a group meet or something like that where you guys are talking and working together. I do also encourage you to seek out the tutors, link up with the tutors, and you can work on this stuff with them. I also encourage you to come to question with class. Say, this is why I'm doing the homework because I'm totally sleepy now. I've been talking about this since 9 this morning. I'm totally falling asleep. Come to class with questions, right? But if you're not in attendance, like if you just get your attendance and then leave, which you're well within your rights, you're missing out on a valuable source. But it's okay. It's totally okay. Are there any burning questions before we go our separate ways? All right. So as a recap, so this week we're working on section 1.3 functions. Our exam 1 will be available this upcoming Sunday at 11:11 a.m. and it'll be due in 7 days after that at 11:59 p.m. on Sunday, right? Going into Monday morning. We get unlimited attempts at the exam, and the system is going to take our highest score. Even though it's due the following Sunday at 11:59 p.m., you can work on it past the due date with the 10% late penalty up until the hard deadline at the end of the semester. Okay? If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Peace.